Okay, this is Unit 12C, Part 2, and we're looking now at standard quotas in education. So we've got this university called Capital University. It's got 5 different colleges with the following number of students in each college. And there's a total of 18 academic advisors, kind of like counselors, that must be allocated to the 5 colleges according to their size. So the bigger the size, the more advisors they're going to get. We want to find the standard quota for each of the colleges. And so the first thing we need to do is find that standard divisor. So our standard divisor, we're going to take and add up all of the numbers. So you get 560 plus 1230 plus 1490 plus 1760 plus 2340. And then we need to divide that by the total number of academic advisors that we have, which is 18. And we get a standard divisor of about 410. So we're going to allocate approximately one academic advisor for every 410 students. And now we need to find the standard quotas for each college. So the first college, you take 560, divide it by the standard divisor of 410, and you get about 1.37. Okay, the next college, and we don't have names for these colleges, so I'll just do them in different colors. You take 1230 and divide it by 410, and that one turns out to be exactly 3. Those are pretty rare instances. Jumping over to our next college, the standard quota there, take 1490, divide it by our standard divisor, 410, 3.63, and then we got a couple more colleges here, so that 1760 divided by 410, you get 4.29, and then our last college standard quota is going to be 2340 divided by 410, which is 5.71. So those are all the standard quotas for the different colleges at this university. So it could be like a college of science, a college of humanities, a college of arts, and so forth. And then, with these decimals here, though, we'd have to find out, who gets more. So who gets rounded up, who gets rounded down, and so forth. And so one method was what's called Hamilton's method. So the United States conducted its first census in 1790, presenting Congress with its first task of apportionment almost immediately after the ratification of the Constitution. So Alexander Hamilton, then the Secretary of the Treasury, championed a simple apportionment procedure that works in the following manner. So after you find the standard quota, so you got to find that standard quota for each state. First, you give each state the number of seats found by rounding its standard quota down. So if it was, if its apportionment was 3.99, you'd round it down to 3, and this is what we call the minimum quota. Then, if there are at the end, if there are any seats left over, so you give each state its minimum quota, and then you look at the fractional or the decimal remainder from the standard quota, and you give the first extra seat to the state with the highest fractional remainder. So 3.99 is going to have much more priority to get a leftover than someone who had 14.1. And then if you have 2 seats left over, then the next state with the second highest fractional remainder gets another one, and so on until all of your seats have been allocated. So here's a look at how this would work. So if we've got our population of states A, B, C, and D, and sorry, that does say population there. Here's kind of a chart how you'd break this down. So there's 5,000 total. The population is 5,000 in total, and we have, in this example, there's 100 representatives. So first we're going to find the standard divisor, which is 5,000 over 100, which is 50. So we got a standard divisor of 50. So to find the standard quota for A, I'm going to have to really squeeze this in here, but you take 914 divided by 50, and you get about 18.28. And you're going to do that for all of these. So you're going to find the standard quota. So then 1186 divided by 50, 23.72. 2192 divided by 50, 43.84. And then 708 divided by 50 is 14.16. Standard quota should always add up to the total number of representatives you have, or the number of apportionments you have. So the minimum quota for state A is, again, I'm just going to take off those decimals. So it's 18.28, so the minimum is 18. And the next one is 23, 43, and 14. I'm just cutting off the decimals. Now if I add up all of those numbers right there, that's 98. So this means I have 2 remaining seats that I need to fill in. So the fractional remainders, this one was 0.28, state B was 0.72, state C was 0.84, and 0.16 for D. So the extras, the 2 remaining seats, are going to go to the 2 highest. So the first one is the 0.84. So state C, it's going to have at minimum 43 plus 1 more, so it gets 44. The next highest is state B, which has the fractional remainder of 0.72, so it takes 23 and we add 1 more, so it gets 24. And then state A and state D get that minimum quota that they had. And notice if we add together 18 plus 24 plus 44 plus 14, we now have our total of 100 seats. So the 2 remaining seats, we had to look at the fractional remainder and then divvy those out to those who were closest or had the biggest fractional remainder. And that's how Hamilton's method works. It's very straightforward. It's very simple. However, it has some limitations, especially when it comes to fairness. Okay, so although the Hamilton method did not become law at the time it was proposed, it was reintroduced and adopted as an apportionment process in 1850. It remained in use for almost 50 years until 1900, and during this time several problems with the Hamilton method emerged, and the most famous is what's called the Alabama paradox. So after the 1880 census, the chief clerk of the census office, there's his name, used Hamilton's method to compute the apportionment for various states. And their house sizes. Unlike today, in those days the house size often changed with each apportionment. It kind of grew and grew. So he discovered that Alabama would get 8 seats in a House of Representatives, or a House of 299 representatives. So Alabama's, if there's 299 representatives, 8 seats would go to Alabama. However, when they increased that number to 300, the math came out to where Alabama actually lost a seat. So 1 seat was added to the House of Representatives, but Alabama's population didn't change, but using Hamilton's method, they lost a seat. So this curious result definitely seemed unfair because we increase the total number of seats, yet Alabama loses a seat. So that's what we call the Alabama paradox. We're adding extra seats it actually did a counter effect on Alabama, and one state or more in the Alabama paradox loses a seat as a result of adding more using the Hamilton method. Now, just to note, Alabama did not actually lose a seat in 1882 apportionment because Congress chose a larger House size of 325, and the Alabama paradox did not present itself. But knowing that the paradox was possible, there was a lot of support that was lost for Hamilton's method, and it was abandoned in 1900. So we're going to look at this question here. 26, so we have 3 states, A, B, and C, and we see their populations right here. So we're first going to assume 100 representatives must be apportioned to the given populations. We're going to determine the number of representatives using the Hamilton method, and then we're going to switch over and say, well, what if we increase that to 101? Determine the new number of representatives for each state and see if the Alabama paradox occurs. So first, again, we need to find our standard divisor. And so you've got to add 2540 plus 1140 plus 6330. And we get a total population of 10,010. So I should write in these populations. So this is 2540. This is 1140. This little chart really helps out to be able to keep your information organized. So 10,000. Oops. 10,010 is our total population. So our standard divisor, and we're dividing this by 100. So divide it by 100. So our standard divisor is 100.1. So the standard quota for A, take 2540, divide it by the standard divisor, and you'll get about 25.37. So the next one, take 1140, divided by 100.1, and I get 11.39. And then 63.24. So again, they should always add up to the number of representatives you have. The minimum quota, just going to truncate or take off those decimals, so 25, 11, 63. And if I add all of these up, I fall one short. There's 99. So I have one remaining that I need to allocate. So the fractions or decimal portion that's left over is 0.37 for state A, 0.39 for state B, and 0.24 for state C. So the final apportionment, state B is going to get the only additional one, so it'll take 11 plus one more, so it will get 12, and you'll remain 25 and 63 for the other 2 states to get your total 100. And again, that's using Hamilton's method. So in the next video, we're going to look at what happens when we bump up this the number of representatives to 101. So it's going to change our standard divisor, it'll change our standard quotas, and we're going to see if the Alabama paradox occurs in our next video.